Hi everyone, this is the notes for solving radical equations. So you probably already filled out this section and you can take a look at the steps here. The idea is that we're going to isolate one radical expression on one side of the equation, and often that's already done. And then we're going to raise both sides of the equation to the power that's the same as the type of radical. So basically, if we have a square root, we're going to square both sides. If we have a cube root equals a number, then we're going to cube both sides to get rid of it. So then we're going to solve the resulting equation. And then if there's still a radical, we're going to do the same thing again. So we're going to get the radical by itself and then start over. So we always want to double check our possible solutions to make sure that they aren't extraneous. So we want to make sure that they satisfy the original equation, because sometimes that can happen when we have square roots. So I'm going to go ahead and solve this one. So the first thing I need to do is get the square root by itself. So I'm going to subtract 3 on both sides because that's not underneath the radical sign. So I have 2x minus 1 equals 2. I'm going to square both sides. It's going to cancel the square root and the square. It drops out x minus 1, or 2x minus 1 equals 2 squared, which is 4. From there, I'm going to add 1 on both sides. I have 2x equals 5. And then I want to divide by 2 on both sides. X equals 2.5, or 5 halves, depending on which one. Then we want to make sure that we can check it, so I left this empty box here. So 2 times, I'll use 5 halves here, that's more helpful to me, minus 1 plus 3 should be equal to 5, that's what we're checking. So I know that 2 times 5 halves would just be 5. So I have the square root of 5 minus 1, which is the square root of 4, which is 2, plus 3 is equal to 5, the original 5 that we needed. And we know that that is true. Therefore, we know that x does indeed equal 2.5. If we finished this whole process here and we found that it actually didn't work, then what we would say is that 2.5 is extraneous. And we'll see one of those problems here. So go ahead and try this next one. It's very similar. If you want to check your work, you can check it on Canvas, and then you should get x equals 6. So take a moment, pause, and try this one, and then come back to the video when you're ready. So here we have a slightly different problem. If you want to try it on your own, the answer is that it's extraneous. So we'll check out what that looks like here. So I have one of my radicals is by itself, so I'm going to square both sides. What that means is the square root and the square will cancel, leave x minus 2 equals. And then on this one, this is like saying 2 square root x plus 4 times 2 square root x plus 4, which is really like outsides with outsides, insides with insides. So the 2 times 2 would give me 4. And then radical x plus 4 times radical x plus 4 would just give me x plus 4, like that. So this would be still equal to x minus 2. I'm going to go ahead and distribute in here. So I have 4x plus 16 equals x minus 2. I'm going to add 2 on both sides, subtract 4x on both sides. I get negative 3x equals 18. So we'd say that x equals negative 6. From there, I'm going to go ahead and plug it in to make sure that it works. So I'm going to plug in, anywhere I see x, I'm going to plug in negative 6. So negative 6 minus 2 should be equal to 2 times the square root of negative 6 plus 4. And right here I can see that this is going to be negative 8. And there's no real solutions when you have the square root of a negative number. So at this point, I know that there's no real here, which means that x equals 6 is not a solution. Which means that it is extraneous. So we would say no real solution here. So that's what we would get. There are no solutions because that is extraneous. I'll go ahead and show you another one here, and then maybe 2 more here, and then I'll try one. You guys can try one on your own. So the most of this video is just going to be like doing problems. So if you want to try them, you're welcome to. The next one is that 0 is extraneous and 5 is the answer. The one after that has the answer of negative 122. So we'll try this one together. So I want to get the square root by itself. So just this part here, which means that the 1 needs to go. So I'm going to move that over here by subtracting 1. So I get square root of 3x plus 1 equals x minus 1. From there, I need to square both sides to get rid of the square root. So I'm going to square both sides here. It's going to leave out 3x plus 1. And then this is really like the box, right? So x minus 1, x minus 1. If you complete the box, you get x squared minus 2x plus 1. I see that there's an x squared term and x's that can't cancel, so I'm going to go ahead and move everything to one side, preferably the side that x squared is on. That's going to give me 0 over here is equal to x squared minus 5x, and these actually cancel. So then I know that has a GCF, so I can go ahead and take that x out. X minus 5 is equal to 0. That means that x should be 0, or x could be 5. So it could be one of those answers, it could be both of those answers, it could be none of those answers. I need to go ahead and double check. So I'm going to look here. I have 3 times, I'll try 0 first, 0 plus 1. Plus 1 should be equal to 0, right? Because this is an x, so we know that x we're plugging in at 0. So I'd have square root of 0 plus 1, or square root of 1, which is just 1, plus 0 plus 1 equals 0. That is not true. So we could say that 0 is extraneous. That's what we have here. And then the other solution that I'm going to check is 5. So square root of 3 times 5 plus 1. I have plus 1 outside, should be equal to 5. So I have the square root of 16, which I know is 4, plus 1 should be 5, which it is. And so we could say that x is indeed just equal to 5. So we'd say this have one real solution, which is x equals 5. And then finally, we have one more different kind of problem, which is just different because it has a cube root. So I'm going to go ahead and get rid of the things on the outside. So get rid of the 5 to start. Negative 2 cube root x minus 3 equals 10. Dividing by negative 2, I get the cube root of x minus 3 is equal to negative 5. I want to go ahead and take this to the power of 3. So I'm going to cube both sides in order to cancel a cube root. So I'm going to leave out x minus 3 is equal to negative 125. I'm going to add 3 on both sides. I get x is equal to negative 122. I'm going to go ahead and check this, plugging into the original equation, 5 minus 2 cube root of, there's an x, I'm changing it to 122, minus 3 is equal to 15. From there, start with the inside part here, so that is negative 125. The cube root of negative 125 is negative 5, which is still being multiplied times negative 2, subtracted from 5. So I have 5 plus 10 would be equal to 15, which it is, which means that x does indeed equal negative 122. Right? So you've seen a few problems here. Feel free to go back and rewatch them if you are still thinking about any of them. Go ahead and pause your video here and try this one. You should be getting x equals 2. X equals 2. So try this one on your own. It's very, very similar to the first one that we did up here in the blue. So check that one out and watch the second video for the next one. You can also go ahead and do this one. Both of these are on Canvas, and you can see the full marked out solutions if you click on Canvas. Cool. Try those and then watch the second video. Thanks, guys.